Okay, today we're going to be focusing on resource histograms, which is part of the critical path analysis chapter of modelling with algorithms for further mathematics. Okay, so a resource histogram is another graphic, looks like a cascade chart, gives you some information about the project. Displays how many of a particular resource is being used at any particular time. Usually the resource that is being illustrated is the number of workers. However, this isn't necessarily always the case. For example, the resource might be a cement mixture used by some activities, or perhaps a crane, or perhaps a knife. Moreover, in most cases, an activity is carried out by one person or uses one resource, but sometimes an activity requires more than one person, and sometimes, as you saw in my previous video, an activity requires no one. It might be an automated activity or one being done by a machine or something. It just takes time. So what does a resource histogram look like? Well, it is essentially something that looks like this, which tells you how much of a resource is being used at any one time within the project. We always have a time axis along the horizontal, and then we would have a count of how many of that particular resource is being used at any given time. Okay, so that's what a resource histogram would look like. Okay. All right, so let's have a look at some questions. So this question is one that we looked at in the previous video. We had activity H, didn't have anyone needed to do it, and then we drew a cascade diagram based on this project. And that cascade diagram looked like this, or cascade chart. Okay, each bar represents an activity and each row represents a worker. So we set worker 1 doing the critical activities, worker 2 then did C, G, J and L, and then worker 3 did A, D, F and K. I did make a mistake in the video, but all of that is activity K. Okay, so the second part of that question, which wasn't revealed in the previous video, is draw a resource histogram illustrating the number of workers being used for this project. So what we've got here is my resource histogram. It's currently blank. We've got a time axis that goes up to 30. It's going to have the same scale as your cascade chart. And then on the vertical axis, it's got how many workers are being used at any one time. For this situation, all I'm going to do is just have a look up these bars and just count how many activities are being done at any one time. Each activity requires one person. So we can see for the first 3 units of time, 3 people are needed. And then after 3 units of time, it drops down to 2 because person 3, worker 3, has finished activity A. That remains then at 2 workers all the way to 10 units of time. It's going to be horizontal all the way across there. Until activity D is now being undertaken by worker 3. And he couldn't do that any earlier because activity D required B to be finished. So he couldn't start that back here. So he had to wait until then. From that point, it's full all the way, 3 workers all the way up until 29 units of time. So that's up until here. And then workers 2 and 3 both finish what they're doing at the same time. So that's going to drop down to 1 worker. For the last unit of time, he's just finishing off activity M, and then that's going to drop down to 0. Horizontal bar across the top, like so, and that is the resource histogram for the number of workers for this project. Resource histograms are always just made up of a series of horizontal and vertical lines. Sometimes you might see resource histograms filled out with letters in the boxes. Is to illustrate exactly what resources, what activities are being underdone at any one time. So you might have B, 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 for example. Activity E goes there. Activity I goes in there up until that point. And then M, 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 M. What you may find though with these type of diagrams is you don't have to create bars like you did the cascade chart. So we might have A and A in like that, and we might have C, C, and then C carries on down here until we get to 11. So it might look something like that. It's just representative of how many workers are being used and which activities are being undertaken at any particular time. The actual histogram is the perimeter of the shape. It's nothing to do with what's actually written inside. Okay. Right, so that's example number 1. Let's have a look at example number 2. So we've got this situation here. Again, I think this might be one that I created for this video actually, so I don't think we've seen this this activity on Arc Network yet. But what we've got here is we've got a cascade chart, which I'll show you imminently. It shows the activities of this project. They're starting at the earliest start time. Okay, so just like the cascade chart, the first cascade chart from my previous video, it showed all the activities starting at the earliest start time. And then we're told that activities B, D, F, and H all require a crane. No other activities require that. And then we're told to draw a resource histogram for cranes for them from this cascade chart. So here's my cascade chart. What I've done here is I've put all the critical activities on one line, and then all the non-critical activities have their own line. So we've got B, C, D, F, G, H, and I, and that's because A, E, and J are all down here. So I've just kind of condensed it a little bit so that all the critical activities are together, and then each we can see where all the other activities occur. Underneath that, I've got my histogram, which is currently blank, and we're going to do a histogram for the cranes. So just to remind you of the question, activities B, D, F, and H all require a crane. So I'm only interested in B, D, F, and H, nothing else. So there's B, there's D, there's F, and there's H. So we just put a little mark on those, B, D, F, and H, so we can see exactly which activities I'm interested in. Those are the 4 activities which require a crane. So my histogram for the crane then is going to be 1 crane for the first 3 units of time, which is probably going to be weeks. Okay, then it's no crane until we get to 6. Then it goes back up again. So no crane there, back up to 1 crane until we get to 10. Then we're going to need 2 cranes because both D and F are occurring for the next 2 units of time. But after 2 units of time, activity D then finishes. Is then going to drop back down to 1 crane. That's going to remain at 1 crane here while activity F carries on between 12 and 14. And then activity H starts at 14 and finishes at the same time F does. So that means it's going to go up to 2 again. And then it's going to drop back down to 0 because there's no crane needed after H and F are finished. Okay, so there's my resource histogram for the crane for this cascade chart. Okay, so that would be the answer to this question. Okay. Onwards. Only 1 crane is available. Oh, that's an issue, isn't it? Because I wanted 2 cranes for this cascade chart, so that's an issue. What's the new minimum completion time for this project? Draw a new cascade chart and resource histogram. So just by the wording of this question, I'm inferring that there is going to be a delay in the overall completion time of the project. And that's an interesting point about critical path analysis. When you're performing critical path analysis and you're doing the forward pass and the backward pass, all of these numbers assume you have unlimited resources. They assume you have an unlimited number of workers. They assume you have an unlimited number of cranes in this case. But in reality, that is not the case. It is very uncommon to have multiple cranes or 2 cranes if you're only going to use 2 cranes for this amount of time. It makes sense to rejuggle things if you can, but that can cause a delay in the overall completion time of the project. So how do we go about answering this then? We need to draw a new cascade chart. So just to remind you of the old one, it's only B, D, F and H which I'm really interested in. The issues are here and here. Because those are the times when I need 2 cranes. The critical activities are affected, so I could put those in straight away. And in fact, let's just do that quickly now. And then I'm going to have to delay F, and then I'm going to have to delay H so that only one crane is used. So A is going to go up to 6, which is there. Then we've got E, which goes up to 14. And then we've got J, which goes up to 19. Okay, so that was the original trio of critical activities. Okay. Then the other activities, I'm just going to put in the ones that require a crane first. So B is going to go here to start with. So B goes in there. Oh yeah, it's one per row. I don't need to put B there. I will anyway. D then can't start until 10 because it required A to finish. Oh, not 10, 6. Sorry, 6. And then goes up to 12. Right, looking here, starts at 6, finishes at 12. F would have started at 10, but can't because the crane is being used by D. So F has been pushed back. It's now going to start at 12. It's F, which then is going to push H on as well. So H now has to go off the end of F, which is over here. That takes 2. And then I cannot be started until H is finished, which means I has been pushed on as well. So I will go in there. The other activities should be able to fit in without any problems. So C started at the same time as D, so that can still happen. It is worth checking to make sure that they can still all go in their places. G can still go there. Look at the network, it just requires C to have been finished. So G can still start here, and that takes 3 units of time. There we go. And that's all the activities now. Okay, so B, D, F and H were the ones that required a crane. So now we've got our minimum completion time. I is not finished now until 21 units of time, rather than the 19 created by the critical path. So the new minimum completion time for the project is 19 units of time, days, weeks, whatever it was. And then it also asks to draw a new histogram for the crane. Done the cascade chart. There's my cascade chart. A new histogram for the crane. Okay, so B took a crane, so that's 3 units of time there. Then D took a crane, that happened at 6. D and F and H all take cranes, they keep going until 20. And then I doesn't need a crane, so that then drops back down to 0 again, and then stops. Okay, so that's what the new histogram looks like. And we can see that that no longer goes above the number 1, which is good, because we've only got 1 crane, which was the whole issue. Before we had 2 cranes, we needed 2 cranes, but we don't have 2 cranes. Okay. Brilliant. Well, thank you for watching. That was resource histograms. We've got one more video to come on critical path analysis, which will be on crashing the network. Again, as always, if you have any questions, just drop a comment and I'll get back to you when I can. Thank you very much.